Now let's see how you train your CNNs with this simple gradient descent algorithm. So you have n training examples, right? Xi is your image, Y is the label, and let's say Fx is your feed-forward network, which takes image as input, and it will make some kind of prediction, which should resemble this label. And then you need some kind of loss function, which will again take like the parameters of the network, theta over here, and it will take the image and also the label. All right. So with all this, all these set of information, what this loss function will do, it will tell you how good your network is doing, right? As we discussed earlier, it will just give you one number, and you will use that one number to actually update your weights, and the way you will update the weights is based on gradient descent. Okay, so that one number is actually nothing but some position in this curve, right? And based on that number, if you compute the derivative, you can actually move towards the minima, and you can update the values of your weights. All right, so this x-axis is like your model parameters, and this is the loss function of your CNN. And at any time, like if you have certain set of weights with any input, if you try to predict the loss function or the loss value using the loss function, you will be like at any of the locations in this curve, and all you want is you want to move that point to the local minima. Okay, so let's quickly go over like some of the loss functions which can be used to estimate how good your network is doing. And the most popular one is cross entropy, and I think you will use this a lot. And I will also try to briefly explain like why it actually works. So the simple equation for cross entropy is, so you have the hat is the predicted value, and the value without a hat, that's the ground truth. Okay, so let's treat this value as 0 or 1. 0 means the object is not present. 1 means the object is present. Now, what is happening here is, let's focus on this first term first. Okay, so this is the predicted value, and this is the ground truth value. Let's consider a case where your object was present, right? And your network also said like it is present. So in this case, this is going to be 1, and this is going to be 1, right? So log 1 becomes 0, and this whole term becomes 0. And your network was actually doing a very good job because the object was present and your network said the object is present. Okay, so we are happy, the loss is 0. Now, if you look at the second term, because the ground truth is 1, this completely becomes 0. So we don't have to compute this. So if your network did the right job, your loss is 0, which means this loss function is actually doing its work, right? Now let's consider the other case when, let's say, the ground truth was 1, but the network said it's not present. Okay, so in that case, what will happen is, let's ignore this first one. Let's go to this. So in this case, this will be 0, that's the predicted value, and log 1 is going to be 0. Again, you can ignore this term, because if you just multiply anything with 0, that's going to be 0. Now let's come back to this one. Log 0, you know, is negative infinity, right? And this is 1, so this is going to give you negative infinity, and you have a negative sign outside, which makes this infinity. So which means that if your network is saying, okay, it was not present, but in fact it was present, this kind of loss function or cross entropy is saying, okay, the loss is infinity, which is actually good. And what you do is you compute that loss function for all the samples in your training set, and you just average that. Okay, so that's one kind of loss. You can also compute like mean squared error. This is just you do pointwise comparison. Right? You just subtract the values and you square the values and just take the mean. Okay, so that's fine. Again, this is just telling you the difference between these two. So if the difference is like 0, these two will cancel each other, right? But if the difference is high, it will give you like some high value, which means the loss will have some non-negative value. So this is another kind of loss you use. Okay, so let's actually end it here, and we will continue the second part, differentiability, maybe in the next lecture.